Okay, in this video, we'll go over problems in week 4 regarding counting problems. Now, before we look at those problems, let's quickly review the so-called multiplication principle, which is the cornerstone in counting problems. So what is the multiplication principle? The multiplication principle says this: suppose we want to finish a task, and the task can be separated into several steps. For here, let's say 3 steps: step 1, step 2, and step 3. And also in each step, there are one or more than one ways to finish the step. For example, in here, say we have 4 ways to finish step 1. We have 3 different ways to finish step 2, and there are 2 different ways to finish step 3. Then the question is the total number of ways to finish the task equals 4 multiply 3 multiply 2, which is 24. Okay, it's not, okay, so it's not 4 plus 3 plus 2, which is 9. So this is not correct. What you should do is you should multiply them together. So this is called multiplication principle. Now, an important example is the permutation. Okay, so permutation is, suppose you have n people or n items. Okay, so here, say we have n people, or in general, say you have n different items, and we want to arrange them, right? You say, okay, we want to arrange them. Then the number of ways to arrange them and to shuffle them equals n factorial, which by definition is n times n minus 1 times n minus 2, and all the way times 2 times 1. And the reason is, this is just a simple application of the multiplication principle, because basically you have n spots, right? Or we say n positions to accommodate these n items. Now, step 1, we say, okay, we want to finish, we want to put for the first spot, and then you have n options, right? Because you have n people, whatever. But step 2, you try to fill the second position, but the first one is already the one item is already used, or we say one people is already assigned a position. So you have n minus 1 options, such and such. So the last one will be have 1 options. Then the total will be, you just multiply them together, right? So this we call permutation. Okay, all right. Now let's look at those problems. Problem number 1. How many 3-digit numbers has a digit product, right? So the digit product, let's say this is A, B, C. It's A times B times C equals 30. All right, so let's factorize 30. And because each digit is between 0 and 9, okay, so we have 3 ways. We have 2 ways to do it, right? So number 1, what we can do is 5 times 2 times 3, okay? And the number 2, we can do the factorization is equals 6 times 5 times 1. But then, of course, we can, those are, let's say, number 1, right? You have 3 numbers, 5, 2, 3. Then you can do permutation. Here's 3 numbers, you can do 5, 2, 3, right? So, okay, I can do 2, 3, 5, 5, 3, 5, 2, and such and such. And we know because you have 3 digits, so the number equals 3 factorial, which is 6. So, okay, heck here is similar. You can do permutation, right? You can do 651, 156, and such, right? Again, this is the shuffle of 3 numbers. And we know this is given by the factorization 3 factorial, 3 times 2 times 1, which is 6. Okay, so then we just get total, right? So, okay, so the total just add them together, right? You have 2 cases, we add them together, we get 12. Right? So this is also called so-called addition principle, because you just add all different cases together, right? So this we call addition principle, right? We just add all cases together, which is very natural, right? Okay. All right, so the answer is 12. Now, question number 2. Ms. Lavang want to choose 1 girl and 1 boy from her class to attend the writing competition. If she has in total 72 options, how many students are in Ms. Lavang's class? Okay, Miss Laban class, we can start in two groups, right? The group of all the girls, and then the group of all the boys, right? So this is the girls, and this is the boys. Let's say the number of girls is n, the number of boys is n. Then, okay, so you want to choose one from here and one from here, and then by multiplication principle, right? The total number of our combinations. Combinations equals, you just multiply together, because step one, you say, okay, I choose a girl, right? Then I choose boy, right? So let's say this is step one. You can say, all right, if we formally say, okay, step one, we choose girl. Step two, we choose a boy, right? And we finish the task of forming the team of computation, right? So then we do multiply together, and the total number here tells us is 77, right? Okay, then you see here, okay, we just need to factorize 77. How many ways we can do that? We can do 7 times 11, which is okay. Or you say, hey, why can we do why can't we just do 1 times 77? Which is fine as a calculation, but here the requirement says each gender has more than one student. So if it's 1 times 77, that means either you have only one girl or have one boy. So this one is not valid according to our requirement. Okay, so then what you have is 7 times 11. That means either you have one, it's okay, either you have 7 girls, 11 boys, or you can have, say, 7 girls, yeah, you can have, say, 11, you can have, let's say, 11 boys or 7 girls. Doesn't really matter, because here we're looking for is how many students are in Mr. Lavan's class. So what you should get is 7 plus 11, which is 18. Question number 3. The kids from MSI Chess Club attended international chess tournament. During the tournament, each kid in the MSI Chess Club played once with every other kid in the same club, and 6 times, right? 6 times in total against kids from other club. How many games had the MSI Chess Club participate? All right. Okay, so here we have 10 kids, right? Yeah. 1, 2. Okay, so this is MSI Chess Club. 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Okay, so what we have is each 2 of them. So for each kid, let's say this kid, right? So we play once with each other kids in the group, right? In the group. Okay, all right. And then it also plays 6 times with kids from other clubs, right? 6 times. Okay, so then if you look at all the total games, the total number of games that involves MSRI participants will be, obviously, you have 2 parts, which, okay, we can separate 2 parts and internal games, right? Okay. When I say internal games, means the games between members of the MSI Chess Club. And obviously, this is just 9 plus 8, right? Because you can, if you could do like this, right? It will be 9 plus 8. Okay, 9 plus 8 and plus 7 and all the way to 1. And this is the arithmetic sequence. We know just 1 plus 9 times 9 divided by 2, which is 45. Or if you want to calculate this, or you can use combination. This is the number, the internal number just equals from 10 choose 2. So this is a combination, is 10 choose 2. Okay, because you have 10 club members, right? You just choose 2 of them to play a game, because only play once. And the order doesn't matter, because only matters is the pair and play the game. So there we use combination. So combination. All right, so this is just a simple example. Combination means the order doesn't matter, and there's 10 choose 2, so it should be 10 times 9 and divided by 2 times 1. Okay, if you know the formula, then you use it. Otherwise, it doesn't really matter if you don't know it, which is fine. But if you know this combination is 10 times 9 divided by 2 over 1. Okay, so you get this 45, and you see it's exactly the same, right? Here, the reason why divided by 2 times 1 is because when you do 10 times 9, you apply the multiplication principle, but that the order matters. So you have to correct that by divided 2. Okay, all right. So 45, and then we do the external game. Right, external games. Each member plays 6 times, so it obviously will be 6 times 10, which is 60. Okay, so we then add it together. It's okay. The total will just be 45 plus 60 is 105, right? Question number 4. To make a non-vegetarian fajita, right? So this is the task. The task is to make a fajita at a low-pass grill. You must choose, okay, we must choose a flour or corn tortilla. You must then choose 1 type of meat from 4 types offered. You can then add any combination of extra, including you say, okay, I don't want an extra, which is fine. There are two extras offered are cheese. Okay, 2 extra offered are cheese and the lettuce. Then the question, how many different fajitas can you make? Okay, so here it's clear. The task is to make fajita, and there are several steps, right? Step 1. Step 1 is you choose. Okay, choose. So each step involves several options, right? Choices. Step 1, you choose either flour or corn tortilla, right? Okay, step 1 is for tortilla. Okay, it's for tortilla. And step 2 is you choose the meat, right? We say, okay, there are 4 types. 4 types of meat. And step 3, what you do is you choose extras. Now, extras, there are two different extras, right? You say, okay, they're cheese and they are lettuce. Okay, so let's say this C, this is L. Now, how many different options you have, right? Different combinations, the number of combinations. First of all, you can choose both of them. It's okay, I want 2 extras, or you say, okay, I don't want lettuce, I just want cheese. Or it's okay, I don't want cheese, I want the lettuce. Or you say, okay, none of them. And then you say, okay, so here you have find it's 4 combinations. So you say, okay, I have 4 combinations. Now, another way to get to here, we just list all of them together, right? Or you can buy the combinations. Okay, here I have cheese and lettuce, right? Well, for cheese, either I choose yes or I choose no. Okay, I want it or don't want it. So I have 2 options. And lettuce also yes or no. I want it or don't want it. So for step 1, I have 2 options. I choose, okay, so step 1, okay, let's say we can put it here the way I choose this. Step 1, I choose cheese. I want it or not want it. So I have 2 options. Step 2, I choose lettuce, yes or no. You want it or you don't want it. Or either 2 options. So multiply together, you get 4 options. So this is another way to get here 4 combinations instead of listing them out. But anyway, okay, so now let's go back to our main task. So this is our main task. It involves 3 steps. So here is step 1, we have 2 choices for tortilla. Step 2, we have 4 choices for meat. And step 3, we have 4 different combinations of extras. Then we say, okay, by multiplication principle, the total number of different fajita you can make, just different number of ways to finish the task, equals you multiply to 2 times 4 times 4, which is 32. Question number 5. How many 3-digit numbers, how many 3-digit numbers have no carryover when added? So when added to 456, so we added this, right? And the requirement is no carryover. Well, if it's no carryover, then obviously I know that for this one, the choices will be 0, 1, 2, 3, and 4, right? So that's choice for this. Okay, and then choice for this will be 0, 1, 2, 3. Oh, this is 4, is not cannot. You can only for 3, right? Okay, so this will be 3, 1, 2, and this will be 4. Okay, all right. Now, how about this? So the choice for this will be, because you cannot be 0, this the hands digit. So you can have 1, 2, 3, 4, 5, right? Okay, and then you see, well, that just means you have different steps to finish the task. Each step you determine 1 digit. So the first one, how many choices? Okay, the number of choices. So this is 5 choice. How many choices you have for this? 5 choice. How many choices you have for the last digit? You have 4 choices, right? Then the total will be use multiplication principle. So by multiplication principle, the total will be 5 times 5 times 4, which is 100. Okay, question number 6. How many non-congruent triangles can be formed by joining 3 vertices of a cube? Okay, let's see. So this is a cube, right? It has 8 vertices. So this is vertex, 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 and this is vertex. Okay. Now let's see those non-congruent triangle. So first of all, you see this is a triangle, right? Now the okay, so this is 1. Then you see also, can I do like this? This is 1, another one, right? Which is also a right triangle. Okay, so this is the second one. How about others? Yeah, I can find. If you look at others, again, you have to make sure they're non-congruent. So we we search around to see whether we can find one which is different, right? Which is different from these 2. And then we spot, we say, okay, if I do this, right? If I do this, then I get this is equilateral. Keeping this look, it's clear, right? Geometrically clear. This is equilateral triangle. So if you combine together, you see you find 3 non-congruent triangles. Okay. Question number 7. On the map shown, there are a number of routes from the math field. So we start from here and ends up to here. Each route must travel along the roads in the direction marked by the arrows. The total, okay, here we're looking for the total number of routes from math file to algebra term. Okay. Here, because of the arrangement, what we can do is we just do a enumeration. Just means we just list out all the possible ways, right? Okay, all right, let's do it. So first of all, you have, this is one way, right? So this is one way. And then you can also do this, this. So this is 2 way, right? And then you can do this. So this is the 3rd way, right? And then of course you can do this is 4th way, and you can do this is 5th way, and you can do this one. So this is the 6th way, and you can do this. Yeah, so you can just keep it doing, right? So you can also do this, and then you can do this. Okay, so if you list all of them out, you find exactly. Okay, so this is this is the 7th, right? And this is the 8th one, right? Okay, so in total there are 8 number of ways to go from math file to algebra top. Okay. Question number 8. Mike's garden is divided into 5 sections. He wants to plant flowers chosen from 3 different kinds. If each section has only 1 kind of flowers, and the flowers of the same kind cannot be planted in 2 adjacent sections, in how many different ways can Mike plant flowers? All right, so here we have flowers. So flower 1, let's say flowers, types of flowers. We have flower 1, flower 2, and a flower 3. Okay, let's put this way. we want to finish the task. So what's the task here? The task is to plant the garden. And we do different steps. So step one, we can say, okay, first, let's plant the middle one. Okay, so that's right here. Let's plant the middle one. Obviously, the number of options, right? So the number of options equals 3, and there's no restriction. You can plant whichever type you like. And then we say, okay, for step 2, I want to plant this section. Plant this section. Okay, so plant this section. Okay. For this section, because you see, suppose you already plant flower 1 here, right? Type 1 here, because it says the same kind of flowers cannot be put in adjacent, and these two are the adjacent, right? Because that you see they're adjacent, they have the common, they have a common portion or boundary. And then I know for this part you have only 2 options. Okay, so the number, you get the number of options equals 2, right? Because you cannot choose flower 1, you can only choose flower 2 or flower 3. Okay, so let's say, for example, here we choose flower 1. For example, here we choose flower 2. So let's say, okay, we put a flower 2 here. And then step 3, plant the remaining sections, right? So okay, we plant those remaining sections. Now you see, if this one is flower 1, flower 2, now you have this one has to be, flower 3, no other choices, because otherwise it will violate the requirement that same kind cannot be next to each other. And then this one has to be the second type, and this one has to be the third type. Okay, so then you see that the number of options, so number of options equals 1. All right, so you have 3 options for this, you have 2 options for that, you have 1 option for the remaining sections. Okay, so then we apply the multiplication. And from here, right, from here, we get the total number of ways equals 3 multiply 1, 2 times 1 times 1, which is 6. Okay. Question number 9. In how many ways can 3 boys and 2 girls stand in a row so that 1 boy stands in the middle, and 2 girls are not next to each other? All right, so you see here we have 5 spots, right? And the goal, the task, is to line up these 5 kids by the requirement. So we know a boy has to be here, right? A boy has to be here. Let's say we have boy 1, boy 2, boy 3. So those are the boys. And then we have 2 girls, right? It's girl 1 and girl 2. I just try to find ways to label them. Now, okay, so you have to accommodate them. You can do this in 2 steps. I say, okay, for me, I would say, all right, let's try to accommodate 2 girls first, right? So this I put as step 1. Now you can choose to accommodate 3 boys first. It doesn't really matter, right? Okay, but anyway, so here I think it's more convenient to do 2 girls because there are requirements that they cannot be next to each other, right? Okay, step 1, place 2 girls, right? Because they cannot be next to each other, so you can put it here, right? You can put it here. Here, right? So this is one way, or you can put here and here. This is another way, or you can put here. Oh, hold on. Then you can put here and here, or you say we can put here and here, right? You can put here and here. Right. Yes. Okay. Okay. So you can put here and here, right? All right. Then the number of ways, so here the number of options, right? Just to accommodate 2 girls equals 4. And you have to multiply by 2. Say, why do you multiply by 2? That's because you can switch them, right? For each, let's say, for each placement, you can switch them. Okay, so you have 8 number of ways to place 2 girls. And then we have step 2, right? after we have to place 3 boys, right? 3 boys. Now, because after the position of girls are fixed, then let's say the girls are all here, right? So we have the girl here. Then boy, the position for boys are fixed. You have boy, 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 and then the only 3 that you can have is you just shuffle. You just shuffle them, right? You just shuffle them. Okay, and that's just a permutation. It's 3 factorial. The number of options. Yes, okay. So the number of options is a permutation 3 factorial, which is 6. Then it's okay. What's the total? The total will just be the number of ways from step 1 times the number of ways from step 2, right? Okay, so that's the multiplication principle, which is 48. Problem number 10. How many 3-digit numbers? So here we have 3-digit numbers are less than 600. I've had at least one odd digits, right? One odd digits. Okay. Here the principle is because here you see the word at least, then usually when you see this, it's more convenient. And put this way, it's more convenient to concede the opposite, because the opposite will just be no odd digit, right? So that's what's the opposite. The opposite will be all digits are even, right? All digits are even. Okay, let's count the opposite. Let's count the opposite. Opposite is all even, which is much more convenient. Then, you know, for this digit, you have 5 choices. So you have 5 choices because they are all even. So 0, like 0, 2, 4, 6, 8, right? And for the second one, also 5 choices, right? And for the first one, because don't forget, you have the requirement is less than 600, and also you have to be even. Then you see you only have 2. You have only 2 options for the first one, right? For the 2 options. Why? Because you can only put either 2 or 4 here. Then we know the total invalid cases. That means just opposite cases equals 2 times 5 times 5, which is what? Which is 50, right? Yeah, 50. Okay, so those are the invalid cases. Now, what's the total cases without the requirement, right? If you don't consider the requirement, then the total cases will just be 500, right? Just 500. So that just means all 3-digit numbers that are less than 600. We don't consider any restriction. Then the total will be 500. And then we know for 50 of them, all are even. Then we get the number of valid cases, that is at least 1 digit is odd, will be the total minus the opposite, all of them even, so which is 450. Problem number 11. Let the S be the collection of all 5-digit numbers consisting of digits 1, 2, 3, 4, 5. And then we arrange the numbers in S from the least to the largest, right? And what's the remainder when in the list? If you look at the 113th number, and you find the number, and to see what is the remainder when that number is divided by 11. Now you see that the total number of numbers, right? Numbers in S, this is permutation. You have 5 numbers and you shuffle them around, and how many ways you can do that will just be 5 factorial, right? So which is okay, which is 120. And then we list from the least and to the largest, right? To the largest. So least which is the first number, right? Which is the first. The largest will be 120, right? What's the least? Clearly, it's 1, 2, 3, 4, 5. What's the largest? It's 5, 4, 3, 2, 1, right? 5, 3, 2, 1. And then you, what do we want? We need to find the number we're trying to locate is right here. So that's 100. It's Okay, so the number we try to locate is right here. So it's 113th, right? 113th. And then you can just go back to see. First of all, you can shuffle these three numbers. We know it's 3 factorial, which would be 6. Okay, so if you go up to 6, right? So you get 6 right here, and this will be 115. Okay, and then next one will be 114. So 114 is after you finish shuffle these 3, you will see it's 5, 3, 4, 2, 1, and then next, and then one before it will be 5, 3, 4, 1, 2, right? So that's the number. This is the number, right? So this is the number we are looking for. This is the number we are looking for. Okay, now let's find the remainder. So 5, 3, 4, 1, 2, and divide by 11, right? Okay, so this is 4, 44. This is 94, you have 8, 8. This 61, and be 5, right? 52, and this 62, and this is 5, right? 5, 5, and then you get a 7, right? So the remainder is 7. Question number 12. How many words can be formed by using one edge? Okay, so you have we have 5 positions, right? 5 positions, and we use one edge, one E, one O, and 2 identical L's, right? Okay, now how many ways you can do that? Here, what you can do is method 1. Method 1, first we pretend, right? We pretend these 2L are different. We pretend they are different, right? We say, okay, maybe we put this and this. We pretend they are different. And then we know the number of ways, it just equals to a permutation with 5 factorial is 120. But then, you know, we have to correct it, right? Okay, so then we know we have to correct it because 2L's, they're actually different. And then you see each one is counted twice because if you do L, let's say L and L here, and this is L and this L here, they are actually the same. So each one, and then you know each one actually is counted twice. Now, if you consider, we say, okay, pretend L's are different, and then we get 120, but actually they're not, they're identical. So that means each one actually is counted twice. So the correct answer has to be divided by 2, which is 60, right? Which is 60. Okay, now this is one way to do it. Now, method 2, what we can do is we say, okay, we just use step 1. We just use different steps. Step 1, I want to place 2L, right? I say, okay, let's place this 2L. I have 5 spots. I have 5 spots to place 2L. How many ways? What you can do is, of course, you can just list all of them out. So this is enumeration, and you'll get there 10 different ways. Or if you know combination, or by a combination. So this I put optional. Now, if you know it, then you can use it. If you don't, that's fine. So if you use combination, this will just be 5. From 5 positions, you choose 2 positions to accommodate these 2 identical L's. Because the order doesn't matter, they're identical. So we use the 5, choose 2. From 5 positions, choose 2. And we know the formula. Now, if you know the form is fine. If you don't know, which is okay. If you know it, it'll be good, right? Just use it. If you don't know it, which is completely fine. All right, so then you say, okay, so how you can calculate 10, right? And then after you put this 2L, right, step 2, place the remaining 3 letters HEO, they are different. So you see, if you put this LL here, let's say I put the LL right here, right? And then you have HEO, right? You say, okay, I put HEO here. And all you need to do is you just permute because you can shuffle around. And then the number of ways equals, for here is 3 factorial, right? You can shuffle around, which is 6. And then you say, okay, then total will be by multiplication principle again, by the multiplication principle. Total will be 10 times 6, which is 60, right? Number 13, in how many ways we can put 3 math books? Okay, so we have 3 math books. Okay, I have 3 math books, math 1, math 2, math 3, and then we have 2 novels, novel 1, novel 2, and 3 cartoons, cartoon books. So cartoon 1, cartoon 2, cartoon 3. We put them on a bookshelf, right? So that books in the same category are placed next to each other. For this kind of thing, we use there's something called binding strategy, or we say binding method, because we require in the same category are placed next to each other, so we can pretend they are the same thing. Okay, so we say, okay, we just bind, we pretend one big book, and then we can say this is another big book. This is another big book, right? So it's okay. So then we have the math book, a big math book, a big novel book, and a big cartoon book, right? Okay. Now, all right. So we just pretend that book. So then we say, okay, step 1, what we can do is arrange a category. 3 categories, right? 3 categories to arrange where you put math, novels, and cartoon books. So you get this 3 factorial, which is 6, right? And then, okay, so after you decide where to put a math book, so okay, let's say this I put a math book, and this section I put novels, and this section I put cartoons, right? And then you say, okay, step 2, I can arrange 3 math books, which is 3 factorial, because I can just shuffle around. So this one, I get 3 factorial to do it. And then I can arrange 3 novels within this position. So again, 3 factorials, I can arrange. So arrange 3 novels will be 3 factorial. Arrange 2 cartoon books will be 2 factorial, which will just be 2 factorial 2, right? Okay, so for in second step, we have 3 factorial times 3 factorial times 2 factorial, so which is 6 times 6 times 2. And then the total will be, right? So then we are done, right? After these 2 steps, we have placed all these 8 books, and total will be 6 times 6 times 6 and times 2, right? And then let's see what do we get? 36 times 12, right? 36 times 12, 72, 36. Okay, so we have 432. This is so-called binding method. It is used when you see something like same category has to be placed to each other. Then we can consider the same category, the themes in the same category just as one big item, right? Okay. Question number 14. Ahmad walks up 8 steps, going up either 1 or 2 steps at a time. There's a hole on the 6th step, so he cannot use that step. In how many different ways can Ahmad reach the top step? Okay, so here we have 8 steps, right? Step 1, step 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 8, and 7. Okay. And then, so this is 1, 2, 3, 4, 5, 6, 7, 8, right? Okay, now here the issue is there's a hole on the 6th step, so that means you cannot reach here. Then this basically tells us the only way you can do is, first of all, you find different ways to finish these 5 steps. This is 4, not 5. All right, so first of all, you find ways to finish these 5 steps. And then the next thing you can do, you have to go from 5 to 7. So that means you add 2 steps, and then from 7 to 8, add 1. Okay, that means you have to have 5 plus 2 plus 1, but you have different ways to finish the 5, right? Different ways to finish the 5. Okay, how should we do the 5? Well, we just do different cases, right? We say, okay, case 1 we can do is 1 plus 2, 1 plus 2 plus 2, right? But of course, you can also shuffle around, and then you can shuffle it. For here, you can say 1 plus 2 plus 2 means at first you go by 1, then you go by 2, go by 2, right? Go by 1, then go by 2, go by 2. Or you can 2 plus 1, you go 2, 2, and then 1. Again, you can just shuffle around. And then the number of ways, obviously, the number of ways in this category, in this case, obviously 3, right? That is easy to see. Then case 2, what you can do is 1 plus 1 plus 1 plus 2, right? Then again, you can shuffle it, right? You can shuffle it. You get the number of ways equals 4, right? You can have, for example, you can have 2 plus 1 plus 1 plus 1, right? And then 1 plus 2 plus 1 plus, okay, you have 4 to shuffle it. Okay, how about, can we do others? Yeah, so the third case, each time just go by 1 step, right? Which is again equals 5, right? So they're all equals 5, equals 5, equals 5. And then there's no need to shuffle because all the number of ways will be just 1. They're all 1. Okay, now we just add them together, right? Different cases. From here you get the total, right? So okay, from here you get the total will just be, right? So you get the total will just be 3 plus 4 plus 1, which is 8. Okay. Question number 15. Mayuki text a 6-digit integer to Jillian. 2 of the digits of the 6 integers are 3 identical. Unfortunately, the 2, 3 that Mayuki text did not appear, and the Grill instead received the 4-digit integer 222022, right? The number of possible 6 digits that 6-digit integers that Mayuki could have text is, you see, so here the point is we know that 2, 3 are missing, right? 2, 3 are missing. Then basically asking 3 could appear between here, like in the middle. They could have combined together. They could appear in the front, like here and here. Okay, so that basically just you put 3 into these 5 different spots, right? Okay, all right, you just put there. Let's look at 2 cases. Case 1, 2, 3s together. Case 1, 2, 3s are together. Then obviously you have 5 ways, right? You have 5 ways. You can just write them out. We have is, okay, so we can have is 3, 3, 2, 0, 2, 2, 2, 3, 3, 0, 2, 2, 2, 0, 3, 3, 2, 2, and 2, 0, 2, 3, 3, 2, and 2, 0, and then 2, 0, 2, 2, 3, 3. Okay, so basically just you combine the 3 and you put into 5 positions, right? 5 positions. Now case 2, 2 3s are not together, right? Are not next to each other. All right, so then what you have, the solution you have is 2, 0, 2, 2, right? You say, okay, I have 5 spots and I have 2 3s to go to those 5 spots. Then the total number of ways equals, you can count them by enumeration, just list all of them out, or, okay, method 1, number of ways. Method 1 is just enumeration, just list all of them out. And we actually did this before. You have 10 different ways to do it. Method 2, use combination. If you know the concept of combination, you can use it. Because this is basically from 5, you choose 2 spots, right? Here you see you have 5 spots. 1, 2, 3, 4, 5, right? 5 spots. And then you choose 2 positions, right? You choose 2 positions to accommodate the 2, 3, because they are not next to each other. All right, so then we have 5 times 4, 2 times 1, right? So that is 10. This is the same. All right, okay. And then the total will be, because you have 2 cases, case 1, we get is 5, case 2, we get is 10. So the total is just add different cases together, which is 15, right? Okay, so question number 16. The diagram shows a square board in which strips of white squares alternate with the strips of black and white squares. A larger board constructed in the same way has 49 black squares. How many white squares are there on the larger board? If you look at the pattern, you'll quickly see that this is 1, 2, 3, and then the length is 7, which is the length of the side length is 3. Okay, the side length is 3 times 2 and plus 1, right? So that's side length, which is 7. Then if you go to something, you have 7. Here is you have 49, right? 49 means you have 7 black, right? So in each row, this is 7. You have 7 blacks, right? 5, 6, 7, right? Okay, and then we know from here we get this the side length. The side length will be, what's the side length? The side length will be 7 times 2 plus 1, which is 15, right? Which is 15. Then you say, okay, from here we get the total. Total means black plus white, which will be 15 times 15, so it's 225. Black, then the white will be what we are looking for. We are looking for white, right? And then the white will be the total 225 and minus black, right? Black is 49, so this is black 49. Okay, so then we get is 176. Question number 14. There are 26 students in the class. Okay, 1/3 of them we know will be 12. 12 of them attend a math after school program, and half of them will be 18 attend a science after school program, and 1/6 of them, that will be 6, attend the both program. How many of them attend neither program? This is we use the typical. This is a typical situation to apply the Venn diagram. Okay, so what we do is you see 1/3 of them, so that's 12, right? So, okay, so 12 of them attend the math after school program. And then we have 18 of them. 18 of them attend the science program, 18. And the overlap, so that's 6 of them, like both of them. So 6 of them attend both. So that's the overlap. Total, we know what's the total. The total is 36. And what we're looking for is this portion, which is in neither program. Okay, so first of all, let's figure out what we need to do is, okay, we just figure out what's the number in one of them, right? In one of these science programs, which is 12 plus 18, but you have to subtract the overlap because it's counted twice. And then we know this is 24, right? So, okay, so we get this 24. Accordingly, this portion will be 36. This portion will be 36 minus 24, which is 12. Number 18, a pet farm has 220 Labrador retrievers and golden retrievers. 115 of them are female, 120 of them are Labrador retrievers, and 15 of them are male golden retrievers. How many of them are female Labrador retrievers? Okay, for this kind of problem, let's draw the picture, which will be convenient for us to see what happens. Okay, all right. So here we have it's let's say this is a male Labrador, and then we have male Labrador, and then we have this is it's a female, right? It's a female Labrador, and then we have this is a male the golden retriever, and this is female golden, right? Okay, we divide into 4 sections. Now let's put those information, those numbers in this figure. In total, we have, it's okay, total is 220, that's total. 115 of them are females. Okay, so that's why here I say, all right, females combined together is 115. 120 are Labrador retrievers, so 120, so that's combine this together is 120, so combine. Now, and 55 of them are male golden right here. So it's 55 are male golden retrievers. Now from here, we quickly get, because the total is 220, and then we'll get this portion, right? It's okay. Then we'll get this total, this part. We'll get this part will be 120 minus 120 minus 220 minus 120, right? 210 minus 120. So this part we know, okay, will be 100. So there are 100 golden retrievers, and this is 55. So 55 of them are 55 of them. Right? 55 of them are male. Then female will be equals 100 minus 55, which will be 45. And then because the total female is 115, and then female labranda will be 115 minus this is 45. So then we get is 70. Number 19, 50 dimes and 6 quarters are randomly placed in a row. Let n be the largest possible of consecutive, right? Largest possible consecutive dimes in a placement. What is the least possible value of n? Okay. All right, so here we have 6 quarters, right? So okay, we have 6 quarters. So this is a quarter. This is a quarter, right? So this is a quarter. This is a quarter. This is a quarter. All right, and we can put the dimes either between the quarters, on the front, or in the back. Doesn't really matter, right? Okay, so we have basically we have 7 sections. Okay, so from here we have 7 sections to accommodate. So this is like section 1, section 2, section 3, section 4, section 5, section 6, and there's one more. Okay, forgot there's another coin, another here. So this will be 7, right? So there are 7 sections to put dimes, right? To put dimes. And then let's see how many dimes we have 50. Okay, so then if I do 50 divided by 7, it'll be 749 divided by 1. That means I cannot put like each section no more than I cannot put 7 in each section. You have to, one of them has to be bigger than 8, no less than 8. So I get at least one section, right, has 8 or more, right, has 8 or more dimes, right, 8 or more dimes. And then you see, okay, if I put, for example, I can put this like 8, then this will be 7, 7, 7, 7, 7, 7, right? 7, 10. And then for this particular arrangement, you'll find this will be the n, right? So this is the longest. This is the longest consecutive dimes, which that's 8, right? You cannot go down by 8 because this one tells you regardless how you do it, you always will find one section that have 8 or more consecutive dimes, right? Okay, so the answer is 8. Question number 20. There are n different colors of balls in the bag. Each color has at least 4 balls. Okay, John randomly picks 13 balls, which can ensure that he get at least 3 balls of the same color. What's the largest possible value of n, right? This one and the previous one, they are basically something we call the pigeonhole principle. Pigeonhole principle. Okay, now let's see how we do it. Okay, so here first of all we have n different colors of balls, right? In a bag, the n different colors. This is n different colors. Now, if I try to get balls, if I say, okay, I'm insure, right? I want to insure 3 balls of the same color. Let's consider the opposite. Consider opposite. What's our opposite? The opposite is like I want to avoid 3 balls of the same color. If I want to avoid 3 balls of the same color, then what can I do? Well, then what I can do is I can choose 2 balls from this type of column. Then I choose 2 balls from this, 2 balls from here, and 2 balls from here. So that's the best I can do, right? At the best, I can choose. We say, okay, so let's say John John can choose is 2 times n, right, to avoid 3 balls of the same color. So that's at the best, so it's at the most. Therefore, if I add 1 more to it, this will guarantee. So this number will ensure there are 3 balls of the same, 3 balls of the same color, right? At least 3 balls of the, at least avoid at least 3 balls. There are at least 3 balls of the same color, right? Okay, now I want, of course, this number balls because it has 13, so that means 13 cannot below this number, so this number has to be less than 13. From here, you get m is less equal to 6, right? Get m less 6. So the largest possible number will be 6.